Hey guys, so we have another cool project for you guys. In this video, we're going to be making a autonomous motion tracking airsoft gun turret. It's going to have a webcam mounted on it to detect motion, and it's going to be controlled by two stepper motors, a Raspberry Pi, all mounted on top of a rotating platform. There's also going to be an interactive mode where you can remotely control the gun turret and move it around and fire the airsoft gun. In the first part of the video, we're going to show you how to make all the mechanisms so you can move the gun and fire it. In the second part of the video, we're going to show you how to load the code in there so you can make your own. Because we're going to be using an airsoft gun and firing projectiles, please make sure to use the proper safety precautions like wearing safety glasses so nobody gets hurt. So this is what the concept of our gun turret is going to look like. We have a airsoft MP5 gun mounted on top of a couple legs here, controlled by two stepper motors. And this is all going to be on top of this rotating platform here, which is going to be slightly raised above a base here, connected by a flange collar in between. You can also use a Nerf gun if you would like. Most of the materials we have you can find at a store, in the websites we're going to link, or in 3D printable files that we will link as well. I'm going to go through this model one component at a time so you can kind of see what the build process is going to look like and how it's all going to come together. So if we clear everything out, we're going to start with the base here, which is the circular piece we're going to cut out of a MDF material that's going to be about a 1/4 inch thick. On top of that, we have a flange collar. So this flange collar you can either buy online, which could be a little pricey, or you can use our 3D printable files that we're going to link in the description. If you don't have access to a 3D printer at your local library or university or at home, then you can also purchase some pre-made 3D printed parts printed on our own 3D printer. So on top of this flange collar, we're going to turn a stepper motor upside down and mount it to that flange. You can notice that on this motor there are 4 holes on the bottom, and we're going to use these holes to mount our rotating platform. And they're just mounted with some metric screws. They're about 3 millimeters. So on top of this, we're going to have a couple legs. These are also made out of MDF, just like the rotating platform and the base here. And these are going to be mounted onto the platform with some 90-degree angled brackets that we're just going to screw into each piece. So on top here we have a couple holes for the second axis of rotation, and so the gun is going to go right in between there. To mount the gun onto these legs, we're going to use another identical flange collar here, which we're just going to glue on the side of the gun. And to connect that to the leg, we'll basically use our stepper motor to go through the hole in the leg into the flange collar and screw the motor into the leg, just like we did with the motor here down at the bottom. On the other side, we're going to have a flange shaft that we're also going to 3D print. If you don't have a 3D printer, or you would not like to purchase our parts, you can also make this part out of a piece of wood or another piece of MDF and glue a dowel sticking out of the wood or MDF. So that should work as well. And we'll probably have some electronics on this rotating platform. The camera may be mounted either on the base or on the rotating platform, depending on if we want the camera to move with it. So this is basically what our concept is going to look like.
You'll need a few materials in order to build this project. As always, we'll link those materials in the description, and we'll post the files to our 3D printable parts on the hackaday.io page. Okay, the first thing you're going to need is this 1/4 inch thick piece of MDF. It's just a big square. I think it's about 2 feet by 2 feet. And this is going to make the base and the arms that hold up our airsoft gun. You're going to need a couple metal brackets. These are 90-degree angle brackets, and they're going to hold up the arms, which support our airsoft gun. You'll need an electric airsoft gun. This is ours. We just got it off eBay. You can also use a Nerf gun if you want, but it has to be electric so that we can wire it into the Raspberry Pi. We have assorted screws. These are half-inch length screws, number 8, and then we also have the 8 3mm screws. These are to mount the stepper motors, and some assorted washers. These are just number 8 washers. These are our 3D printed parts for holding the gun in place. And then for the electronics, we have a battery, which is just like a cell phone charging battery. You can get these online on eBay. But it just has a couple of USB ports here, and it outputs 5 volts. So we'll need 2 micro USB cables to power our different components. In order to drive the turret, we're going to use these stepper motors. These are NEMA 17 stepper motors. You can also use servos to do this, but we decided to use stepper motors because we had a few of them lying around. They're also pretty cheap. They're about 10 bucks each. And you can do a full 360 with them instead of being limited by 180 degrees with servos. In order to drive those stepper motors, we're using this Adafruit breakout board. You can buy these online. It's a kit, and you have to solder these connections on. And the stepper motors will be driven by 12 volts. So since our battery is only 5 volts output, we have this step-up converter. And this just feeds into the motor power here, and then you have your 2 motors connected onto this, and this is driven by I2C. And of course we have our Raspberry Pi 3 on the bottom here. And then finally, for the computer vision aspect of this project, we're going to use a simple webcam. This is a Logitech webcam. I'm not sure exactly what model it is, but we'll link it in the description.
We have our MDF material here. We're just going to cut about 2 pieces about 9 inches in diameter, one of them for the base and one of them for the rotating platform. The motor is going to be connected to that top platform and controlling the rotation, and it's going to be connected to the bottom platform with our flange collar. To mark the circle that you're going to cut, you can use any piece of string or power cord. What I have here is a probe from my multimeter, and I'm just going to use that to trace my circle around. Since our circle is going to be about 9 inches, our radius is going to be half that length, so 4.5. So I'm going to just put one side of my string at the pivot point at the start of the tape measure and measure about 4.5 inches right there. I'm going to grab my pen and put it just at that length and draw my circle. We're going to be using a jigsaw to cut this MDF. If you don't have a jigsaw, that's okay. You can just use a regular saw. You can just cut a square piece. We just wanted to use this so it looks a little nicer. And as always, remember your eye protection. Since I already made one of these, I used it as a template to make my second one. Now I'm going to measure the diameter of the circle so I know where to mount the motor. Because it's not a perfect circle, I'm just going to take measurements of a few different diameters, divide it by 2, and mark the center, and hopefully get an approximation from the average of those locations. Now that we have the center of the hole, we know where the shaft goes. But we also need some holes for the 4 screws on the motor. How we're going to do that is we're going to shove a piece of paper through this shaft here and then just poke holes where these holes would be. So 1, 2, 3, 4. And now I can put this on the MDF and mark those holes. Now I'm going to use a 5/16 drill bit to drill through the center where the shaft will go through. And I'm also going to use a 1/8 inch drill to go through my mount holes. One thing I forgot to mention is MDF dust is not very good to breathe in, so it's always a good idea to wear a dust mask when you do this. Now we're going to use some 3mm screws and a few small washers to mount our motor right in the center. Now to mount the flange collar onto the base. So I've already measured the center, and I'm going to put this flange collar right into the center here and screw those in with some number 8 1/2 inch screws. And once that's mounted, I can insert this shaft right into the center of that collar. Now I can put the top platform on. There's a little notch in the shaft that I'm going to attempt to line up with the flange collar. These are the dimensions that we picked for our leg for the gun turret, and these numbers are just arbitrary, so you should pick numbers that make sense for the gun that you decide to go with. But ours ended up being about 6.3 inches on the bottom and 7.8 or 7.9 inches up to the pivot point. And we had a hole in the middle for our pivot that was about 1/2 inch, and this is for the side with the shaft going through it. You'll probably need a slightly bigger hole for the side where the motor mounts. And then we had a diameter of about 2 inches going over the top. With the dimensions we gave you earlier, we made some paper templates, cut them out with scissors, and laid them on top of this MDF to trace out what are going to be our legs. So we're going to use a jigsaw to cut these pieces out, and then we're going to use some brackets to mount them to our platform. So using the legs we just made, we're going to have to drill a few holes in here to mount our motor. One drill bit we're going to have to use is the 1/8 drill bit to mount the motor screws, the 4 holes that mount the motor onto the stand. And then we're going to have a 5/8 drill bit to drill through the center here for the shaft of the motor to go through. And then for our other leg on the other side, we're going to drill a 1/2 inch hole, and this is for the 3D printed part we built. To get the center hole of our side pieces to line up well, we're going to drill through both pieces at the same time. And to find the center, we're just going to use a tape measure to roughly measure the center of it and about 1 inch down from the top. And then we're going to clamp them down here on the table and drill through with our drill. You'll notice that we have 2 wire leads coming out of the gun here. The reason for that is we wanted to be able to fire the gun by powering it with our electronics. So you see if I put these 2 wires together, that connects the batteries together and shoots the gun. But we had to take it all apart and put it all back together, and it was actually pretty difficult to do. Alternatively, instead of connecting these wires to the trigger, you can open up the battery compartment and connect these batteries together. If you look on the cover here, you can see that these two batteries are connected using this metal strip, and these two batteries are connected using this metal strip. So you can instead solder a wire or just tape it on there to connect one pair of batteries. And then with the other pair, you can wire one lead to this and one lead to this, and basically just have the same thing as we have here. However, if you do that, you would have to tape down this trigger so that the switch is always activated inside, and you'd also have to tape down the safety. So we just attached the stepper motor onto the holes that we just drilled, and on the other side, we put a second collared flange onto our shaft. Now we're ready to mount our legs onto our rotating platform. To do that, we're going to use a 90-degree angled bracket, and we're going to screw them right onto the MDF with some number 8 screws that we have. The ones we have are about 1/2 inch long, and they may go through the side, but that's okay. If the screws stick out a little bit, it will kind of be on the inside, and it will be hidden. And for the rotating platform, since it's above the base, the screws will stick out underneath, where it's kind of hidden in between the rotating platform and the base. So now that I have the parts on the leg assembled, including our brackets, we need to decide how far apart we need to screw these into the platform. To do that, you can measure the width of the gun where these flanges are going to attach with a set of calipers or a tape measure, and have that same length in between these two flanges. Using that, we can determine the length between these two legs, and we can use this length to mark on our platform where to screw. And it's okay if you're not exact with these measurements, because there's a little bit of flexibility with these legs. I put these marks a little off center just because our gun isn't really centered between our legs. Now we're going to put some pretty sticky outdoor mounting tape onto our first flange, and after that we can mount our gun.
So I have my Raspberry Pi with my stepper motor hat and the step-up converter. And here are the two stepper motors. So there are two terminal blocks on here for the different stepper motors. The first one is this one for motor A. We're going to wire in the spinning base to that one. And then we're going to wire in the gun pivot to stepper motor B. You're going to want to make sure that you wire up your stepper motor correctly. As you can see here, my first wire is red, my second wire is yellow, green, then gray. Your stepper motor will have a corresponding data sheet, and you just want to make sure that you wire up your stepper motor corresponding to what the data sheet says the motor 1 and motor 2 wires are. And I'll show you a diagram on screen that corresponds to how I wired this one up. You'll just basically want to make sure that you do that the same if your stepper motor has different wire colors. Take these two micro USB cords and then connect them to our battery, and then take the other end and plug it into both the one for the step-up power converter and one for the Raspberry Pi. And this step-up converter is adjustable, so I made sure to adjust it to 12 volts. Last thing I did was connect this single relay to my stepper motor hat. To do that, I took 2 wires, and on this power rail right here on the stepper motor, I wired up 5 volts and ground to the positive and negative terminal on this relay. And then I took this orange wire, connected it to the GPIO pin number 22, and wired that into the signal terminal on this relay. So when I send this GPIO pin number 22 to high, it will switch the relay from these far-facing terminals to the 2 terminals right here. So what I did was I just wired in the red wire to the center terminal and the black wire to the far right terminal right here. So initially it starts out with these 2 terminals connected, and then when we send this GPIO pin 22 high, then these 2 terminals right here get connected, which fires our gun. This particular relay turns on when you set this source pin high, but some actually turn off when you set the source pin high. So if that's the case, you want to switch this black wire, which is wired up on the right, to be wired up on the left instead.
We use the cheap Logitech webcam with a USB cable on it for our video feed. There's 2 modes, interactive and motion detection. And for interactive mode, we want the camera to follow the gun wherever it's looking. And ours had a little clip that just happened to fit on our site and just rests just like that. But you can use glue or mounting tape and just stick it on top. In motion detection mode, the camera has to be stationary in order for the motion tracking software to work. So we just put our camera on a flat surface in front of the gun. And it could be helpful to use some double-sided tape to keep the camera stationary. When you calibrate the gun, you want to make sure that the gun aligns with the camera.
Okay, so I'm on my Mac again, and I'm connected to the Raspberry Pi via VNC. And you don't have to connect through VNC. You can just hook up a keyboard and a monitor and just do all this on the Pi itself. But I like to do this just because it's simpler for me. So if I click this terminal, I can open up a new terminal. And we're going to want to install a few things on this Raspberry Pi before it'll work with my code. So this is the repository that you're going to be using. This is a piece of code that I wrote, and there's a file in here. It's pretty simple. There's only one file. It's called turret.py, and this is what you're going to be running. And this will work with the turret that you just created. So there's a README on here, and the README will include all of the up-to-date instructions for how to load all of the dependencies on your Raspberry Pi. I haven't filled this out yet, but usually I update this if there's some sort of thing I missed in the video. So if anything's not working properly, I would consult this just to see if there were any changes. First thing I'm going to do is come back here and make sure that I have pip installed. So I'm just going to type sudo apt get install python -pip. And yep, I already had that installed. We're going to use this to install most of our dependencies. If I go back to my web browser, I have this guide for how to configure I2C on your Raspberry Pi. I2C works with the stepper motor hat that we use to control the stepper motors. So we're going to have to configure this before we do anything else. I'll link this guide in the description and also on that README in the repository. Basically, you just have to load a few things, so Python SMBus and I2C tools. And then when you run this command, rasb config, you just follow the prompts down here. There are a few images that tell you a couple things that you have to configure, and then you reboot your Raspberry Pi. Once you do that, your I2C should be configured. I've already done this on my Raspberry Pi, so I'm not going to go through that process. The next thing you want to do is install this Adafruit Motor Hat Python library. There's a repository for it on GitHub. This works directly with that stepper motor hat that I was talking about earlier. And in order to install this, you need to go back to your terminal and type sudo pip install git plus https : / and then the URL of the GitHub repository. So this guy up here, github.com/adafruit motor hat Python library. Okay, so those are the two main dependencies that you have to install. You also need to make sure that you have OpenCV configured. So I found this cool guide online which helps you install OpenCV on Raspbian Jessie. And so since I'm using Raspbian Jessie for my operating system on my Raspberry Pi 3, I use this guide. And most of the stuff in here, you just kind of follow along and make sure that you do all of these things. The one thing you do have to note, though, is after you do all of these commands, it wants you to make a virtual environment for your Python dependencies. You have to add an extra step to that. So down here, they create a virtual environment for their project. And you have to add an extra flag to this. So on the make virtual env CV, you add an additional parameter. So in my case, I did make virtual env -- system -site -packages. The name of my virtual environment, and then -p, and you'll want to use Python 2 for this. So I used Python 2. So when you follow these instructions, like I said, you want to make sure that you follow the instructions for Python 2.7, because the turret.py file I'm using uses Python 2.7. And once you have this command for your virtual environment, you can just go ahead and run it, and it will create a virtual environment for you. This extra flag basically just takes all of the site packages that you already have installed for the stepper motor hat and adds it to your new virtual environment that you create. In this tutorial, I believe it shows you how to activate your virtual environment. But just to reiterate that, basically what you have to do is source your profile, .profile file. So if I do source ~/.profile, it will source the .profile file. And then if I type the command work on, and then the name of my virtual environment. So in my case, I created one called turret. You probably created one called CV. I can work on my virtual environment. And then once you've activated your virtual environment, you can see it in parentheses in front of your command line. There are a couple things you have to do before starting up the turret.py file. There's another Python package called rpy.gpio. You want to install that as well. So once your virtual environment is activated, you have to type pip install rpy.gpio, and it will install rpy.gpio to this virtual environment. So I already had it installed, so it says requirement already satisfied. And then you'll also want to install one more thing. So if I do pip install, there's another Python package called imutils. So it's imutils. This one is used for some of the image processing on the motion detection code. Install that one as well. Finally, you'll want to clone the tracking turret repository onto your Raspberry Pi. So you can create a folder if you want in the home directory. So it looks like I'm in my root directory, so I'm just going to go to home/pi, and in my pi directory I have a folder called code, so I'm just going to go into that folder, cd code. You probably don't have a folder called code, so you can make a folder with mkdir, and let's just call this HH turret. And I can go into that folder by typing cd HH turret. And in order to clone this repository, I need to type git clone and then go over to my tracking turret repository, press clone or download, and then copy this link and paste it over here. Once you've cloned that repository, there should be a folder in here called tracking turret. You can go into that folder by typing cd tracking turret. And now that I'm in this folder, there is a file called turret.py. This file is what you're going to use to run the code on your turret. So if I type python turret.py and I make sure I'm still in this virtual environment, I can press enter. And then there are two input modes here. Input mode 1 is called motion detection, and this uses a webcam in front of the turret to detect motion and then fire at anything that's in front of it. Interactive is a mode that you can control through commands on your keyboard. So WASD moves the turret up and down, left to right, and then enter fires. You can also view video from the camera on your screen with the interactive mode. For now, I'm just going to type 1 for motion detection. It wants you to calibrate the gun. So I'm basically just going to move the gun so that it's level. If your airsoft gun isn't balanced, usually it tilts up. So you just basically want to make sure that's level so that's aligned with the camera. I can press enter, and then it wants me to calibrate the yaw of the gun. So I'll just basically move it left to right until it aligns with the camera, which is sitting in front of it. Live video, you can't use live video on VNC because it's just too much for the VNC to handle. So if you're using VNC to control this, I would say no for this. But if you're connected directly to your Raspberry Pi with a monitor, you can choose yes. Since I'm connected through VNC, I'm just going to hit no. And then it'll wait for the exposure to adjust on your camera. And then when it's finished adjusting, it'll say done, waiting for motion. Alright, so now I have my Raspberry Pi turret hooked up to my projector just so you can see a demonstration of the interactive mode. If I run the python turret.py again and select interactive, it'll ask me if I want live video or not. So for this, I'm just gonna hit yes and enter, and it starts a video that you can see here, and this is on a separate thread. So if I go back to this window and click on this window, I can use WASD to move the turret around, turn back and forth here. And then if I don't have any ammunition in here, so it's safe to do this, but if I hit enter, it'll shoot the gun. The accuracy of the gun is based on where you mount your camera. So on this camera, I mounted it on the top of the gun and kind of tried to align it with the barrel, but it's all dependent on where you align the camera. And then if I want to quit, I can press Q. Alright, that's all for this video. Hope you guys enjoyed this project. The code can definitely be added to. If anybody's interested in either optimizing or adding a few things to the code, I'm going to post that on GitHub. So feel free to make a PR and I'll take a look and merge it in. In our next video, we're going to make a internet connected door lock. You'll be able to add it on to your existing deadbolt and then be able to lock and unlock your door from your smartphone. So if you forget your key while you're going to work, or if you wanted to let visitors into your home, you can just press a button on your smartphone and be able to lock or unlock your door. So stay tuned for that. Otherwise, see you next time.